If you want to break into cybersecurity, just set up a home lab or do a capture the flag challenge. I'm sure you have seen tons of videos or posts that make this claim. But here is the hard truth. Most of these cookie cutter projects, everyone does them, and hiring managers know it. Think about it. If you're trying to stand out and land a security role, especially your very first one, you can't show up with the exact same projects that every other beginner copied from the same YouTube tutorials, because then you just blend right in with the crowd. What if instead you could build mini projects that actually solve the kind of problems real security teams face every single day? I'm talking about practical, case study style projects that don't just show off tools, but prove you can think like someone already working in the field. And that's the difference between getting ignored and getting callbacks. In this video, I'm going to break down simple, realistic cybersecurity projects you can start today. Each one is tied to a real-world problem, just like the ones that overwhelm actual security teams, from tracking risky vendors to sloppy employee access. And I'm going to walk you through exactly why each project matters and what problem it solved and how it proves to the hiring manager that you understand their domain. So, if you're tired of wasting hours on the same old home labs that every other beginner is posting on LinkedIn, keep watching, because by the end of this video, you're going to have a set of powerful, targeted projects that instantly put you ahead of the pack. If you ever felt the same frustration with the lack of guidance or the same boring projects you've done multiple times, please drop a link in the comment. I would love to hear your inputs. By the way, my name is Sam. I've spent over a decade helping companies from mid-sized businesses all the way to Fortune 500 lock down their security programs. And I've coached countless people from zero experience into their first real security jobs. So let's start with GRC. Here is the situation. Imagine you're working for a mid-sized company that uses all sorts of online tools to get work done. Right? Pretty common. These might include payroll software, file sharing platforms, email marketing systems, or even cloud storage services. Each of these outside companies is known as a vendor, or sometimes also called a third party, because your company is trusting them with your data that might be sensitive. But here is a real problem that happens in companies. Nobody's actually keeping track of what data these vendors are handling or whether these vendors are taking security seriously. So if one of these vendors gets hacked, your company could get pulled right into the fallout. You might have to deal with angry customers, big fines, or face legal repercussions. This is what people mean when they talk about third-party risk. The truth is, most companies do a poor job managing it. They either have outdated spreadsheets that no one looks at, or they are scrambling at the last minute whenever a client demands to see proof of security. So here is your mini project. You're going to step into the shoes of someone working in GRC, which again stands for Governance, Risk and Compliance. Your goal is to build a simple system to keep track of which vendors your company is using, what kind of sensitive data they are handling, and how risky each one might be. Think of it like creating a basic security scorecard for all the outside companies your business depends on. Doing this kind of project might sound small, but it's actually a huge deal in the real world. It proves that you understand one of the biggest headaches security and compliance teams deal with, knowing where your risks are before they turn into expensive disasters. When a regulator or a big client comes asking, hey, do you know if your payroll provider is secure? Your company needs to have a clear answer. By doing this project, you're showing that you can think like someone in GRC, someone who protects the business by staying ahead of these issues. How do you start? Step 1, start by opening a spreadsheet in Excel or a table, wherever you feel comfortable, so you have a simple way to organize all of this information. Step 2, set up columns where you will list details like the vendor's name, type of data they handle, for example, customer credit card numbers or employee social security numbers, whether they have any well-known security certifications like ISO 27001, and last column, the date someone checked their security posture. After you have built your tracker, take it a step further by writing a short set of security questions that you might send to one of those vendors. You don't need to make it complicated. Even coming up with 8 or 10 simple questions is good enough. For example, you could ask if they encrypt sensitive data, whether they have a dedicated security team or they have ever had a data breach. Step 4. Once your table and your questionnaire are ready, pick one of the vendors in your sample list and mark them as high risk. Then write a quick note on what you would recommend doing next, like asking them to improve their security controls or even exploring safer options. Step 5. If you are stuck and need inspiration on what kind of questions to include, you can browse the NIST catalog online. It's definitely a bit technical, but even skimming through it gives you ideas on what type of security checks that matter. You can also just search vendor security questionnaire examples, and you will find plenty of practical templates. By the way, if this is helping you out, hit like and subscribe. It tells me to make more videos like this. And if you got a question or a different take, drop it in the comments. I'm always curious to see what you think. Imagine you're working on a security team that is responsible for keeping an eye on your company's systems day and night. This part of the team is known as the SOC, which stands for Security Operations Center. Think of the SOC as your company's frontline defense. They are the ones constantly monitoring activity, watching for anything unusual, and trying to catch problems before they turn into a full-scale security breach. The biggest headache for SOC teams is that they are completely buried in alerts. Every system, from firewalls to login portals, is constantly generating logs and sending up warnings. Most of these alerts turn out to be harmless or just normal system noise. But hidden inside could be that one real sign of an actual security attack. Because analysts have to sort through thousands of these every day, it's far too easy for a genuine threat to get overlooked before it's too late. For example, you might have a user account that logs in from halfway around the world at 3 in the morning. If your team is overwhelmed or not paying close attention, they might completely miss it, even if it's actually an attacker using stolen credentials. Here is your mini project. You're going to step into the role of SOC analyst and practice what it is like to sift through noisy logs and find the serious stuff. Your goal is to take a small dataset of simulated security logs, look for suspicious activity, and then write a short report explaining what you found and what you would recommend doing about it. Doing this project is incredibly valuable because it proves you can think like an analyst. In the real world, SOC teams aren't just looking for people who can operate a fancy tool. They need people who can spot patterns, use common sense, and decide what's truly urgent. By showing that you can dig through logs, find suspicious behavior, and explain your thinking, you're actually doing the kind of work that gets hiring managers to pay attention. Your step 1 is start by finding a small data set of simulated logs. You can download these sample logs from practice platforms like TryHackMe or look around GitHub for repositories that include security logs specifically meant for blue team exercises. Step 2. Open the log file in a text editor like VS Code or Notepad so that you can see the raw data. To take it further, try writing a simple Python script that reads through the file line by line. With Python, you could use the CSV module if it's a CSV file, or even just split lines by spaces or commas. You can look for repeated failed login attempts by the same user, or scan for logins that happen at odd hours, like between midnight and 5 in the morning. You could also flag any entries showing logins from countries where your company doesn't operate. This turns you from someone who is just eyeballing data into someone who can automate spotting problems, which is exactly what modern SOC teams love. Step 5. Once you have found a few entries that look suspicious, write a short alert triage report. Keep it to about half a page. In your report, explain what you discovered, why it stood out to you, and what next step you would recommend. For example, you might suggest blocking a suspicious IP address or forcing a password reset on a user account that seems compromised. Step 4. To show even more initiative, add one simple idea for how you could improve the alert system itself. Maybe you would propose tweaking the rules so harmless activity stops flooding the team with alerts, or suggest adding a new rule that flags repeated failed logins from different countries. Step 5. If you want some inspiration or a guided way to learn how analysts think about these problems, TryHackMe has blue team rooms that teach exactly this. You can also search online for examples of security log analysis case studies to see how professionals break down and investigate suspicious activity. Okay, let's switch to AppSec. Imagine your company is about to launch a new web feature that lets customers log in and see their orders. The developers are excited to push it live, but before that happens, the security team, which is where you come in, needs to look over the code to see if there are any hidden risks. As you start reviewing the work, you notice that one of the developers took input directly from a form on the website and plugged it into the database query without any checks or safety measures. This is a textbook example of SQL injection, which is one of the biggest problems listed on OWASP Top 10. With this kind of a mistake, an attacker could enter a tricky piece of text and trick your database into giving up private information or even wiping out records. It's one of the simplest yet most damaging mistakes a team can make. So here is your mini project. You're going to act like an AppSec specialist, which means someone focused on application security. Your goal is to find and show where SQL injection problem is hiding and then write a short note explaining exactly what's wrong and how to fix it. Oh, by the way, if this all feels a bit overwhelming, I get it, I've been there. That's why I put together a free guide and worksheet to help you figure out the best role for you and prep without wasting weeks on stuff you don't need. Grab it from the link in the description below. It's totally free and honestly, it'll save you a ton of time. So why this matters? Doing this kind of project proves you're more than someone who can just scan using a tool. It shows you understand how to read code, spot serious security holes, and explain them in a plain language so developers know what needs fixing. Companies lose millions from SQL injection attacks, so being able to catch and stop them early is a huge skill. Here are the steps. Step 1. Download a small, intentionally vulnerable attack from OWASP. These applications are made for safe practice. Step 2. Set it up on your machine so you can explore it in your browser and see how forms or login boxes work. Step 3. Open up the source files and do a quick code review. Look for places where user inputs are dropped straight into SQL statements without using placeholders or other security controls. That's a classic sign of SQL injection risk. Step 4. Try it out in a browser. Enter a single quote or something like 1+1 into the form. If you see weird errors or get unexpected access, that confirms the security vulnerability. Step 5. Run a simple scan using OWASP Zap or Burp Suite to let it crawl the site and see if it flags SQL injection issues automatically. Step 6. A short memo explaining what you found. Show the risky code or the payload you used. Explain why is it dangerous and suggest fixing it by using parameterized queries. Step 7. If you want examples or secure coding patterns, check out the OWASP SQL injection cheat sheet or look through the OWASP Top 10 guide for more context. So this gives you 3 solid, realistic projects, from spotting vendor risk in GRC to catching suspicious logins like the SOC analyst, to finding dangerous SQL injection flaws before they reach production. But we're not done yet. In part 2, I'll show you how to build projects for IAM, cloud security, and even how to think like a security architect so you can prove you know how to secure systems before they ever launch. See you in that video.